These are your 8384 notes on multiplying polynomials. We are going to, in this lesson, learn how to multiply a polynomial by another polynomial. Our last lesson involved multiplying a mono by a poly. So now we're going to actually have two quantities. So maybe a binomial times a binomial times trie, or maybe two tries. So we're going to resort back to the distributive property to help us with this concept. So we're going to try to do exactly what we did in the last lesson, is to use the distributive property. So in order to use the distributive property, we have to decide which polynomial we want to break into separate monomials. I usually choose the first one, or I choose the smaller of the two to break up. But there's really no rule in choosing which polynomial you want to break into separate monomials. After you decide which one to break apart, you're going to write a product of each monomial and the remaining polynomial. So whichever one you decide to break apart, each term goes on the outside of the parentheses of the remaining polynomial. And then we repeat what we learned in the previous lesson. We're going to distribute each monomial through the polynomial. And then if necessary, we're going to combine like terms. So let's go ahead and try this. I have three problems here. The first of which is a binomial, z minus 6, times another binomial, z minus 12. So really, there's no advantage to breaking up one or the other. So I'm going to choose to break apart this first binomial. And so what I mean by break it apart is I'm going to rewrite it as a z, and then I'm going to rewrite it as a negative 6. When you multiply polynomials, every term of the one quantity has to get multiplied by every term in the other quantity. So this z in this first quantity needs to be multiplied by z minus 12. And also the negative 6 needs to be multiplied by z minus 12. So you're multiplying every term from the first by every term in the second. And so now we just do some repeat distribution. So we go z times z is z squared. Z times negative 12 is negative 12z. Again, be careful with your signs, be careful with your numbers, be careful with your exponents. When I multiply through this 6, I'm going to actually multiply through negative 6. So negative 6 times z is a negative 6z, and a negative 6 times a negative 12. Negative times negative makes a positive, and the 12 times 6 makes 72. The last thing we have to look for is any terms that need to be combined. I see a negative 12z and a negative 6z in the middle there, which makes negative 18z's. So we leave z squared alone, minus 18z plus 72. And that is the final answer. And number 2, same thing. We have a binomial times another binomial. It does not matter which order you break these apart. Maybe someone might argue that it's easier to distribute a positive 8 rather than a negative 4, but it really makes no difference. So as soon as you commit, I'm going to commit to just the front one. That's usually what I use. So I'm going to take the 5x and multiply it by 2x plus 8. And then I'm going to take the negative 4 and multiply it by 2x plus 8. Okay, if that's one number, both parts are being multiplied by 2x plus 8, we're going to distribute. So 5 times 2 is 10. X times x is x squared. 5x times 8 is a positive 40x. Negative 4 times 2x gives me a negative 8x. And negative 4 times a positive 8 is a negative 32. Again, I look for combining like terms afterward. You're going to find that in these particular cases, you're going to have a lot more times where you have to combine afterward. So these two middle terms, again, are alike. I've got a positive 40x and a negative 8x. That leaves me with 10x squared plus 32x minus 32. And that's your final product. Okay, number 3, a little bit different, a little bit more difficult, because now you have a binomial, 2 terms, and then a trinomial, 3 terms. And what I want to mention is when you have a 2 by 2 up above, right, a binomial times binomial, we actually did 4 multiplications. Z times Z, there's 1 multiplication. Z times 12, there's 2. 6 and Z, there's 3. And then 6 and 12, there's 4. And the reason for that, it's a 2 by 2, which should give you 4 multiplications. And so you have Z squared, negative 12Z, negative 6Z, and 72. There's your 4. The answer, it actually condensed down to 3 terms, but that's just because 2 of those 4 were alike. Same thing in number 2. There were 2 numbers in the first term, 2 numbers in the second term, which leads to 4 total multiplications. So a nice way to check your work as you go. So for number 3, there's 2 numbers in the first term that need to be multiplied by all 3 numbers or terms of the second polynomial. So 2 times 3, there should be 6 different multiplications here. You should have 6 different products when you're done. And some may combine like terms. So we have to decide which one to split up. I'm going to choose 3a plus 4, not only because it's in front, but because it's the smaller of the 2. I find it's easier to break up less and keep the big quantity and distribute through the big quantity. So I'm going to write down a 3a times the quantity a squared. Oh, you know what? There's a little typo here. Let's add an a here. Minus 12a plus 1. And then we're going to take the other term of that first binomial, the plus 4, and multiply it by the same quantity, a squared minus 12a plus 1. So I just added that a in there just to, that's what it really meant. Distribute. 3a times a squared gives me 3a cubed. Remember, if we're still having a hard time with our exponents, you can add a 1 there with the a. A positive 3 and a negative 12 makes negative 36. And an a times an a makes a squared. And a positive 3a and a positive 1 makes a positive 3a. So there's 3 of my 6 multiplications. And then the next 3 will be with the 4. So I'm going to take the positive 4 times it by a squared to get positive 4a squared. Positive 4 times negative 12a, negative 48a. And positive 4 times positive 1 is positive 4. So looking at my 6 products, this is a good place to check. I have 6 different products. That means I didn't forget any. Sometimes people forget them. And then I'm going to look through for different patterns. So I see a 3a cubed is all by itself. I do see a negative 36a squared. And then I have 4 more a squareds. So I'm going to rewrite that as 3a cubed. Doesn't combine with anything. Negative 32a squareds. That's the negative 36 and the 4 together. I see this positive 3a and this negative 48a makes a total of negative 45a's, and then a plus 4 at the end. So we did have 6 products, but we simplified that to make a product of 4 terms. And that's your final product. So that was a binomial times a trinomial. Let's take it a step further. Let's do a trinomial times a trinomial. It's going to take some room. So if you have 3 terms in the first times 3 terms in the second, 3 times 3 is 9. We're going to have 9 different products. It's really important to take your time with these so that you don't mess up. And so again, it really doesn't matter which one you split up. I'm just going to stick with the first term. So I'm going to split up the first trinomial and multiply through the second. So I'm going to have a 2b squared on the outside of b squared plus 3b minus 1. I'm going to put a positive 7b. Include that plus sign so that you know that you're adding that rather than it's a positive 7 rather than a negative 7. B squared plus 3b minus 1. And then plus 9 times the quantity b squared plus 3b minus 1. I'll just move number 5 over. We might have to do that down below. So now we're going to distribute. A 2 times a 1 is a 2. A b squared times a b squared gives me b to the 4th. A 2 times a 3 gives me a positive 6. A b squared times b gives me b to the 3rd. A 2 times a negative 1 is negative 2, and then the b squared. Notice how I say it out loud. You need to do that to yourself at home or in class in your head. Positive 7 times 1 is a positive 7, and then the b times the b squared is b cubed. 7 times 3 is a positive 21, and the b times the b gives us b squared. And then the positive 7b times negative 1 leaves us with a negative 7b. One more time, distribute the positive 9 through. Positive 9 times b squared is 9b squared. Positive 9 times positive 3b is a positive 27b. And positive 9 times a negative 1 is a negative 9. So when I count all those up, I should have a total of 9 different products, which I do. And now we just need to clean up the 9 different products. So I don't see any other 2b to the fourths. So I'm done with that. I might just cross it off a little bit so I don't look there anymore. Kind of helps. Now I'm going to scan the page for all the cubes. I see a positive 6b cubed, a positive 7b cubed, and that looks about it. So that's a total of 13, positive 13 b cubes. And if you want to, I underline them. If you want to cross them off just so, not so you can't see it, because if you have a mistake, you want to be able to see it, but just enough so that your eyes don't go there anymore. We're done with the cubes. Now I've got a negative 2b squared, a positive 21b squared. That makes a total of 19b squareds, positive. And then a 19b squared plus another 9b squared is a 28b squared. So we have positive 28b squared. The fact that they're in circles, I could cross them off, or I just know that they're in circles, so they've already been used. Okay, and then I've got this negative 7b I'm going to draw a flower around, and a positive 27b that I'm going to draw a flower around. Leaves us with a positive 20b, and then minus 9 is left over. So our 9 different products ended up simplifying to 5 in the end. All right, let's look at number 5, a much easier basis, but I want to show you what happens here. So I'm actually going to just show my work down below. So for number 5, maybe you need to do the same. We're going to split up one of them. Really doesn't make a difference. I'm going to split up the first term. So I have an m times an m minus 4 plus 4 times m minus 4. Remember, we're going to keep one of the binomials and split up the other. Distribute m times m is m squared. M times negative 4 is negative 4m. Positive 4 times m is a positive 4m. And positive 4 times negative 4 is negative 16. When I clean this up, I can see my 4 products, which I should have because it was a 2 by 2, a binomial times a binomial. But in the end, a positive 4 and a negative 4 cancel each other out. So we're left with just m squared minus 16. And that's finished. So our 4 terms became 2 terms. And last, I think I have one more problem on here actually, but on this page, on this slide, when you square a quantity, I need you to do something for me. I need to interpret what squared means. So squared means to multiply by itself. So we're going to actually just cross off that squared and actually literally write it down twice. That's what squared means, to multiply by itself. So 2x minus 3 times 2x minus 3. You're going to rewrite it as a product of itself. Now we have binomial times binomial. We're going to break up 1, which they're the same a value. So it doesn't really matter which one you break apart. So I have a 2x on the outside of the quantity 2x minus 3. And I have a negative 3 on the outside of the quantity 2x minus 3. Distribute 2x times 2x makes 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x gives me a negative 6x again. And a negative 3 times a negative 3 gives me a positive 9. Every term took a turn multiplying each other. And so this time, rather than those two middle terms canceling, they're actually the same amount. So a negative 6x and a negative 6x ends up giving us a total of negative 12x's. So we end up with 4x squared minus 12x plus 9. And our lovely little word problem and some geometry. The area of a triangle is 1/2 the height h times the base b. Write an expression for the area of the triangle. All right, so they're asking us area of a triangle is 1/2 the base times the height. I'm assuming that this is the base here, and the height is always perpendicular to the base. And so we've got area is equal to 1/2 the quantity base 6x plus 4 times the height x minus 7. So we actually have three things being multiplied here together here. You could take half of one of those numbers and then multiply by the other. Whenever you multiply 3, you pick 2 to multiply together, clean it up, and then you multiply by the third number. So I'm actually going to pick these two because what I'm seeing is that 2 goes into 6 and 2 goes into 4. So I'm going to distribute, and I'll deal with x minus 7 afterward. So I'm going to distribute my half through, and I get area is equal to half of 6 is 3x, and half of 4 is 2. So that new quantity of those first two terms is 3x plus 2, and x minus 7 is left over. Now we can distribute, break up one of them. I actually, just for fun, I'm going to take this x minus 7. It's a lot simpler, and I'm going to put that on the outside just to mix it up. I told you you could pick either one, so I'm going to pick the one in the back just for fun today, this problem. So x times the quantity 3x plus 2 minus 7 times 3x plus 2. Careful of that negative 7. The negative has to be distributed with the 7. So area is equal to x times 3x is 3x squared, and x times a positive 2 is a positive 2x. Negative 7 times a positive 3x is a negative 21x, and negative 7 times a positive 2 is negative 14. Clean it up. Area of this triangle, 3x squared. I see a negative 21 and a 2, which makes 19, negative 19x minus 14. And that is how you multiply a polynomial by another polynomial. All right, so here's your summary and your practice problem. Good luck.